Go, go, go. Sound check pala. Baka wala tayong naririnig sa inyo.
Hello po.
Ayan,
na po
okay.
ba?
Good na. Sige.
Hi, good morning po. I'm going to report the lesson about counting. What is counting? Counting is the action of finding the number of elements of a finite set of objects. It is also used to determine the complexity of algorithms. Next. Example po ng counting. How many 3-character combinations can be made using letters and numbers? Solution po. So, di ba po merong in the number system ranging 0 to 9 and 26 letters in the ranging from A to Z. So, kukunin lang po yung total nun. Tapos, ang sagot po is 36. Tapos, magkakaroon po na 3 possible spots to place each character and or number. Ito po yung spot. Tapos, ipagta-times nyo po yung 36 ng 3 beses. So, ang magiging sagot po is 46,656 character combination po can be made. Apo.
Ilang individual characters uli yan?
3 po.
3. 3. Oo, 10.
Ano?
Okay. Kasi sa loto ay 6, di ba? Pero that is 1 to hindi, 6 yung output. Tapos that is 1 to may 1 to something. 1 to 42, 1 to 45. Iba-ibang set, no? So, millions yung combination niya. Okay. Alright, sige.
Opo.
Gusto ko makita kung paano binilang. Sige, go.
Okay. Combinatorics. Combinatorics is the study of arrangement of objects. It is an important part of discrete mathematics. We must count objects to solve many different types of problems, like determining whether there are enough telephone numbers or internet protocols addresses to meet demand. Furthermore, counting techniques are also used when probabilities of events are computed. It is also a branch of mathematics which is about counting. Combinatorics also studies permutation and combination. So, i-discuss ko po yun mamaya. Basic counting principle. It can solve a tremendous variety of problems. So, the first basic counting principle I'm going to discuss is the product rule. The product rule is it applies when a procedure is made up of separate tasks. The rule of product rule states that if there are n ways of doing something and m ways of doing another thing after that, then there are n times m ways to perform both of these actions. In other words, when using an for n and the times m different ways para po mas maintindihan ko. Bibigay po ng example. Example, a new company with just 2 employees rents a floor of a building with 12 offices. How many ways are there to assign different offices to these 2 employees? Ang mangyari po, para ma-assign yung 2 employees ay mauna po muna yung isa. So, meron po siyang 12 ways na pumili kung saang office po siya pupunta. Tapos yung kasunod, yung pangalawa naman po is magkakaroon na lang po ng 11 ways. Kaya by using product rule, we're going to multiply 12 by 11 and the answer will be 132 ways po to assign offices to these employees. A basic statement of the rule is that if there are n choices for the action and m choices for another action, and the two actions cannot be done at the same time, then there are n plus m ways to choose one of the actions. Example, a student can choose a computer project from one of three lists. The three lists contain 21, 17, and 22 possible projects, respectively. No project is on more than one list, so how many possible projects are there to choose from? Yung mga student po is magkakaroon ng chance pumili sa tatlong list. Because no project is on more than one list. By using some rule, there are 21 plus 17 plus 22. Ipag-add nyo lang po silang tatlo, tapos magiging sagot po is 60. Magkakaroon po ng 60 different projects in 3 lists. Or in one of ways. To my number 10 math majors and 5 double majors. Mag-a-add nyo lang po yung dalawang major, tapos i-minus niya po dun sa mag-double na majors po. Tapos, mag-itagod po is 25 student in a class. Magpa-plus lang po, tapos minus. Yun na po yung answer.
Okay.
The division rule. There are n over d ways to do a task if it can be done using a procedure that can be carried out in n ways. And for every way w, exactly d of the n ways correspond to way w. Example po. How many ways are there to sit 4 people around a circular table where 2 sittings are considered the same when each person has the same left and right neighbor? Ang gagawin po, ipagpalagay po muna natin na ang circular table are numbered 1, 2, 3, and 4. So, dapat 4 na tao sa 4 na upuan sa ilang pagkakasunod-sunod. So, ano po, 4 factorial po. Magkakaroon po ng 6 na beses po na mauna po yung 1, tapos 6 beses po na mauna po yung 2, yung 3, tsaka yung 4. Tapos rumble na po yung tatlong number. Kaya po 24 ways. However, 2 sittings are considered the same if each person has the same left and right neighbor. So, nangangahulugan ito na if we rotate around the table by the same number of seats, makukuha rin natin yung upo is the same as the original seating. Same number of seats, makukuha rin natin. So, di kami up na upang maka-optim dahil may 4 na magkakaparaan para paikot ang mga upuan. So therefore, by the division rule, there are 24 divided by 4 equals 6 different seating arrangements.
Sige. Napuputol-putol ka. Ayan.
Diagrams.
Ayan. Sige, diretso.
Okay na po ba?
Kanina napuputol-putol eh. Sige.
Sige. 3 diagrams. It is just a visual representation. Diagram. A tree consists of a root, a number of branches with root, and valid additional branches that each noise, and the leaves represent possible outcomes. So, if the output consists of 5 teams, the first team that wins 3 of different ways can the playoff occur. So, nasa colors of yun po yung ways niya. So, are the ano po, antag na po siya, tas na po sa 3. Ito na po yung mananalo. So, at yun po yung ano niya. Visual representation.
Okay.
Pigeonhole principle. The people is one of the ideas in mathematics and can rescue us here. Raised version takes if n plus 1 pigeon by n holes, then at least pigeons. Thus 5 pigeons occupy 4 holes, and there must be some hole with at least just also uses common sense logic. Diba ito pong ito pong picture po dito sa right. There are 4 lang po yung hole niya, tapos there are 5 pigeons. So yung parang straightforward po yung sagot niya. Kasi obvious po yung sagot niya. Kasi po, hindi, yung isa po magsasobra. Kahit saan ilagay ang pigeon ay palagi pa rin may isang hole na more than 1 pigeon.
Wait lang. Kasi ang nakikita ko dito ay 3 diagram. Wait lang. Baka kayo ba anong nakikita nyo? Yung pigeonhole or yung 3 diagrams?
3 diagram din po.
3 diagrams din.
Hindi pa rin pa nalilipat?
Hindi pa nalilipat. Okay. So, i-next mo siya. Medyo mabagal lang yung mo. Yung net mo siguro. Sige.
Okay.
Tsaka, yung merong parang hindi mabilis yung transition. 3 diagrams pa rin eh. Lipat mo yung slide. Okay. Ayan. So, tino-troubleshoot niya muna.
Okay na po.
dun sa ating ano. Ayan, pigeonhole na siya. Okay. Sound check nga uli, ha?
Ayun po.
Ayan, okay.
Hello po.
Ayan, sige. Ito na, pigeonhole na siya.
So, ito po, yung nasa right side po, there are 4 holes, tapos meron pong 5 pigeons. Obvious naman po yung sagot kasi kahit saan po ilagay ang pigeon, ay palagi pa rin may isang hole na more than 2. Ito po yun. So, pigeonhole gives us guarantee of what can happen in the worst case scenario. The reason is that the principle proves that existence of a particular phenomenon. Yun po.
Okay.
Example po, you have 4 stacks and 3 colors. So, may isa pa rin po magdodoble na color doon. Kahit ano po mangyari. Permutations and combinations. Permutation of a set of distinct objects is an ordered arrangement of these objects. We also are interested in ordered arrangements of some of the elements of set. It is used when we are asked to reduce one from previous term for each time. Permutation of n taken r equals, ito po yung formula, permutation of n taken r equals n factorial over the quantity of n minus r factorial. So, example po, hindi pa naglipat.
Hindi pa. Nasa pigeonhole.
Ayun.
Habang na, ayan, permutation na.
Ito po yung permutation, yung formula. Permutation of n taken r equals n factorial over the quantity of n minus r factorial. Example po, 5 factorial over 5 minus 2 factorial. 5 minus 2 equals 3. So, dito yung factorial po, ipagka-times nyo lang po yung number niya pababa po. So, 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Yung 3 times 2 times 1 po, ikakancel nyo na. Tapos, yung 5 times 4 na lang po yung ipagta-times nyo. Equals 20.
Okay.
Yun po yung permutation.
Ganun yung permutations. Alright, okay.
Combination. Combinations are the way of selecting objects or numbers from a group of objects or collections in such a way that the order of the objects does not matter. Combination of n taken r equals n factorial over r factorial times the quantity of n minus r factorial. So, yung 5 po ulit yung n, tas yung 2 ang r. 5 factorial over 2 factorial times the quantity of 5 minus 2 factorial. Ipag-minus lang po ulit yung 5 minus 2, hindi maging 3 na lang. So, if 5 times 4 times 3 times 2 times 1 over 2 times 1. So, ika-cancel na lang din po yung 3 times 2 times 1. And ang matitira na lang po dun sa 5 factorial is yung 5 times 4. Tapos, makakancel na po yung sa 3. Tapos, 2 times 1 na lang po. So, magiging answer po is 20 over 2 equals 10.
Ano yun? Factorial.
Apo.
Okay. Lipat mo ulit kasi nasa permutation pa siya.
Ay,
And combination.
ayaw. Naghahangin. Naglalo ko ata yung laptop.
Hindi, yung net mo yan.
Naglipat na po ba?
Nasa ano pa rin? Combinations. Permutation.
Combination na po.
Combination. Permutation and combination. Ano bang slide to?
Okay po.
Slide 37. Ayan. Nakalagay sa slide 37.
Nasa 38 po yung ano.
Okay. So, ilipat mo dun sa 37.
Ay, Ayan. Combination. Naglipat na po ba?
Okay, 10 na siya. 10 na yung sagot. Yan yung naririnig ko sa'yo kanina. Sige, go.
Ito po yung ulitin ko po.
Oo.
Combination of n taken equals n factorial over r factorial times the quantity of n minus r. So, yun na din po yung kanina. Nadagdagan lang po ng r factorial sa baba. Tapos, ika-cancel lang din po yung 3 times 2 times 1. Tapos, matitira po yung 5 times 4 tsaka 2 times 1. So, 20 over 2 po equal. Dun po solve yung combination.
Okay.
Next, binomial coefficients and identities. Binomial theorem. The binomial theorem is a method ending an expression that has been raised to an infinite power. Binomial theorem is a powerful tool of expansion which has application in algebra, probability, etc. Binomial coefficient is also the number of R combinations of a set with n elements. Ito po yung formula niya. Ayaw ko rin.
Nasa combinations. Yung slide mo ay PowerPoint or Canva?
Canva po.
Okay. So, walang problema yung laptop mo. Ang may problema yung internet mo. Kasi online yung Canva, diba?
Opo.
Yung response time ng ano. Gosh. Okay. Sige, next. Sabihin ko na lang sa'yo kung lumipat na para ano, hindi pa siya lumilipat.
Ay, ano po. Ibang ka-group ko na po yung
Okay, sige. So, yung ibang
Sayang
kagroup
po
mo, anong gagamitin na net? Sana sa kanya yung ano, mas mabilis para mabilis ang lipat. Sige. Ayan, binomial coefficient.
Ayun. Binomial coefficients and identities. Binomial theorem. The binomial theorem is the method of expanding an expression that has been raised to any finite power. A binomial theorem is a powerful tool of expansion which has application in algebra, probability, etc. Ito po yung formula niya. Let x and y be variables and let n be a non-negative integer. X plus y, ito po, x plus y raised to the power of n equals summation of j equals 0 going up to n, combination of n and j, x raised to the power of n minus j, y to the power of I equals the combination of n and 0, x raised to the power of n plus lang po, tapos n, a combination of n and n minus 1, x times y raised to the power of n minus 1 plus the combination of n and n y raised to n. So, kung mapapansin nyo po, yung exponents sa x will decrease by 1. Sa y naman ay nag-increase siya by 1. Example po, kunyari po sa example, yung exponent po niya is 5. Yung a po, magiging, sunod-sunod po siya, yung a po sa unahan, magiging 5 po, tapos yung kasunod na po niya, 4, 3, 2, 1. Tapos yung b naman po is magsimula po siya sa 0. Tapos, 0, 1, 2, 3, 4. Pataas po siya ng, pa-increase po siya ng 1.
Okay.
Binomial expression. A binomial expression is an algebraic expression that contains two dissimilar terms. Ayun po.
Okay.
Next slide. Permutation with repetition. The number of R permutation of a set of n objects with repetition allowed is n raised to the power of R. Proof. There are n ways to select an element of the set for each of the R positions in the R permutation when repetition is allowed because for each choice all n objects are available. Hence, by the product rule, there are n raised to R permutations when repetition is allowed. Counting permutations when repetition of elements is allowed can easily be done using product rule. It is used when we are asked to make different choices each time and different objects. So, example po, how many strings of length R can be formed from the uppercase letters of the English alphabet? Solution po, by product rule. So, di ba po, there are 26 letters in alphabet. So, yung mga letter na yun po is pwede nating magamit na paulit-ulit. So, by using po the formula, yung 26 po yung n, plus e to the power of r, raised to the power of r. Next example, another example po is, di ba po, kunyari, there are 2 dice are rolled. What is the total number of all possible outcomes? So, di ba po, there are 6 sides sa dice. So, yung n po is magiging 6. Yung n po, yung value niya is 6. Tapos, r po is 2. 6 raised to 2 is equal to 36. Yun po yung ganun po yung permutation and repetition. Like.
Okay. At least, nasa tama kang slide.
combinations with repetition. Theorem 2. There are combination of n plus r minus 1, r equals combination of n plus r minus 1, n minus 1 are combinations from a set with the n elements
Ni Aquas.
with when repetition of elements is allowed.
So, yung combinatronics, nagkaroon ng repetition. So, tinawag siya ng combination with repetition. Alright. Okay. Sige.
Yung combination po pala, connected rin po siya sa Pascal's triangle. Kapag yun po yung ginamit nyo, mabubuo nyo po yung, Pascal's triangle
Okay.
na formula. So, example, how many solutions does the equation x sub 1 plus x sub 2 plus x sub 3 equals 11? Half plus equals 11 half. Where x plus 1, x plus 2, and x sub 3 are non-negative integers. So, i-substitute nyo lang po yung, di ba po yung x sub 1 plus x sub 2 plus x sub 3, i-assume nyo na lang po na type 1, type 2, and 3 po yon. So, yung 11 po is yung 11 po yung gagawin nating R. Let's assume yung R is 11. So, yung N po equals 3, tas yung R equals 11. 3 plus 11 minus 1 equals 13, and the R is 11. So, ito po yun. Next is 30 equals 2. Kahit po, gamitin yung combination sa answer. Yung 78 po. So, yun po yung combination with
Okay. Sige. Tatsagaan natin yung ating internet. Balita ko lang sa inyo, yung sa susunod na semester tayo ay magpe-face to face. Pero actually, hindi kompletong face to face. Speaking of problem natin sa internet, bali pa rin, hindi makukompleto kasi yung building natin under repair. So, sabi nila, feedback lang habang ginagawa niya yan. Okay. Raw, magkahalo na na face to face at saka ganito online, kasi wala lang yung nagdadagdag kasi ng another floor dun sa building natin, so dun sa area natin, kaya yung assignment ng room hinahati-hati sa lahat ng courses. Ayan. Okay, ubos na. Sige, continue. Okay. Tapos na. Ayan. Sino next? Ito na ba yung last sa sa group 2? Tama? Okay. Okay, meron pala akong isesend. Sige. Sige, start na. Meron lang akong isesend dun sa ano.
Mag-start na po yung next group.
Yes, start na yung next group.
Hindi po, saglit lang po.
May i-add lang ako. Okay, so habang nagre-ready yung group 2, doon po sa ano natin, doon sa GC natin, since Python yung gamit natin, no, na dito sa interpretation ng ating descriptive, no? So meron doong Python mathematics, which is yung tinakel nung ano, no, tinakel nung group 2. Andun yung meron siyang paano ina-apply yung combinatronics, permutation, ayan, doon sa ano, no. So, and then merong mga exercise dyan, and then solution. So, paano siya nilalagay? Ano yung ginagamit na function or method pagdating doon sa para ma-present sa Python yung permutation, combination, combinatronics, permutation and repetition, ayan, nandyan. Additional info, no? Okay, so balik na tayo dito sa, ready na sila? Sige. Group 6. Sound check.
Nagbagang po ba?
Ayan, okay. Sige, hopefully maayos yung net mo. Na-save siya
Also,
ni Ka.
good morning, ma'am.
Okay.
Good morning, ma'am. Good morning, everyone. We are here to discuss discrete probability and advanced counting techniques. Next slide, please. So, the topics that we need to cover are these two, which is discrete probability and advanced counting techniques. Under the discrete probability, we have an introduction to discrete probability, probability theory, Bayes' theorem, expected value, and variance. Next, in advanced counting techniques, we have applications of recurrence relations, solving linear recurrence relations, divide and conquer algorithms, generating function, inclusion and exclusion, and application of inclusion and exclusion. Next. So, introduction. So, the theory of probability was first developed more than 300 years ago when certain gambling games were analyzed. Probability theory remains popular because of its applicability to gambling. It is an extremely popular human endeavor and it's used in a wide range of disciplines. So, ano nga bang connect nung discrete probability sa course natin, which is computer science. So, in computer science, probability theory plays a very important role in the study of the complexity of algorithms. In particular, ideas and techniques from probability theory are used to determine the average case complexity of algorithms. Probabilistic algorithm can be used to solve many problems that cannot be easily or practically solved by deterministic algorithms. So in a probabilistic algorithm, instead of always following the same step when given the same input, the algorithm makes one or more random choices which may lead to a different output. Next. So, finite probability. An experiment is a procedure that yields one of a given set of possible outcomes. The sample space of the experiment is the set of possible outcomes, while an event is a subset of the sample space. So Laplace definition of the probability of an event with finitely many possible outcomes will now be stated, which is if S is a finite non-empty sample space of equally likely outcomes and E is an event that is a subset of S, then the probability of E is P of E is equals to absolute value of E divided by the absolute value of S, which means that the probability of an event can never be negative or more than now. So, or more than one. So, for further understanding about this topic, we have this example. So, next slide. So, we have example number 1. An urn contains 4 blue balls and 5 red balls. What is the probability that a ball chosen at a random from the urn is blue? So, to calculate the probability, note that there are 9 possible outcomes. Since meron tayong 4 blue balls and 5 red balls, pag adding that up, we have total of 9 balls. So, ang 4 blue balls, there are 4 blue balls dun sa urn. So, hence, the probability that a blue ball is chosen is 4/9. We have another example. So, next. Example number 2. What is the probability that when 2 dice are rolled, the sum of the numbers on the 2 dice is 7? So, all in all, merong 36 na equally likely possible outcome pag sabay pinag-roll yung dalawang dice. So, there are 6 successful outcomes, namely 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1s. Where the values of the first and second dice are represented by an order pair. Hence, the probability that a 7 comes up when 2 fair dice are rolled is 6/36. Pag na-simplify, ang mag-equal doon is 1/6. So, next po. So, we have probabilistic reasoning. So, etong the Monty Hall 3-door puzzle, isa itong sikat na logic puzzle itong sikat na puzzle sa math. So, ano nga ba to? So, let's imagine. Suppose we are in a game show, tapos you are the contestant. So, you have a chance to win a large prize. You are asked to select one of 3 doors to open. The large prize is behind one of the 3 doors and the other 2 doors are looser. Once you select a door, the game show host, who knows what is behind each door, does the following. First, whether or not you selected the winning door, he opens one of the other 2 doors that he knows is a losing door. Then, he asks you whether you would like to switch doors. Which strategy should you use? Should you change doors to keep your original selection, or does it matter? So, regarding dito, pwede ba ako makahingi ng feedback sa inyo kung magpapalit ba kayo ng pintuan or pag may chance kayo magpalit ng door after kayo papiliin nung game show show siya yung host doon, tapos pinapili kayo ng 3 doors, kaso meron ka nang napili. Pero nag-open siya ng isang door, tapos 2 doors na lang yung pagpipilian and binibigyan ka niya ng chance para magpalit ng door. Yun. So, magpapalit ba kayo ng pintuan or mag-stay lang kayo as is dun sa choice niyo? So guys, stay lang daw si Bernard. Yung iba, magpapalit ba kayong pintuan? Stay lang din. pwede ko ba matawag si Bernard? Para kung bakit ka mag-stay lang.
Low. Rinig ba?
Oo.
Pwedeng dinideceive ka lang. Hindi mo ka nalunan yung game. Para hindi ka manalo sa game, ganun.
Thank you sa ano. Wala ba sa inyo na malilipat ng pintuan?
Ako malilipat ako.
Lilipat ka?
Lilipat ako si Ma'am Pain.
Sorry po si Ma'am. Lilipat po kayo. Ano pong reason nyo? Bakit po lilipat po kayo ng door?
Kasi there is always an option eh. What might be in the other door. So, yun yung reasoning ko doon.
Okay. Thank you po, ma'am. So, ang pinaka-solution dyan is, ayun nga, usually, ang tao, nag-stick lang sila sa instinct nila, which is okay naman. Pero when we're talking about statistics and probability, or ayun lang, numbers lang yung pag-uusapan natin, mas mataas yung chance mo na manalo if you chose another door besides your option. Kumbaga, nag-switch ka ng option. Ayun. So, bakit? So, originally, ang chances mo or ang odds mo na makuha yung tamang answer before nung pinapapili ka pa lang ng game show host is 1/3, which is in percentage, 33%. So, may 33% ka na makuha yung tamang answer, yung manalo ng large prize, ganun. So, once na nag-ask na yung host, once na nagbukas na yung host ng isang door, ang chances mo na dun sa kabilang door is magiging 66%, which is proven in statistics and probability na mas mataas yung chance mo pumili ay manalo kung lilipat ka ng ibang door. Kasi yung odds mo manalo sa pintuan mo alone is 33% lang. Yes, while on the other hand, nadagdagan yung isang door ng 33%. So, ayun. So, when you are given a chance by the host na magpalit ng pinto, you should always do that since that will double the probability that you will win.
Saka rin yun, kumbaga parang clue rin yun, parang sinasabi sa'yo ng parang intuition, although lalagyan natin sa atin we're talking about mathematics, no, explanation. So, rin yan parang clue. Pag sinasabi kang binibigyan ka ng mas maraming option. Hindi lang
yes,
dahil dumadami. Parang sinasabi niya na
magbago ka.
Ayun, ganun.
Kami po nag-i-stick sa kung ano na lang po yung kung ano na lang po yung choice nila. Like, feel po nila ayun po talaga yung which is wala naman pong mali doon. Pero when we're talking about numbers, mas mataas yung probability po ng kabilang pinto na manalo po kayo doon.
Kasi nadagdagan yung option.
Opo.
Correct.
So, ayun. Next po. So, probability theory. What is probability theory? So, the definition it is a branch of mathematics concerned with the analysis of random phenomena. The outcome of a random event cannot be determined before it occurs, but it may be any one of several possible outcomes. The actual outcome is considered to be determined by chance. So, next slide po. Under probability theory, we have assigning the probability. So, the function P from set of all outcomes of the sample space S is called a probability distribution. To model an experiment, the probability P of S is assigned to an outcome should equal the limit of the number of times S occurs divided by the number of times the experiment is performed, because this number grows without bounds. So, we will assume that all experiments discussed have outcomes that are predictable on the average, so that this limit exists. We also assume that the outcome of successive trials of an experiment do not depend on past results. So to further understand this, next po, we have an example. So example 1, what probabilities should we assign to the outcome H, which is heads, and T, tails, when a fair coin is flipped? What probabilities should be assigned to these outcomes when the coin is biased so that heads comes up twice as often as tails? So, next po. So, to answer that problem, we have this solution. So, for a fair coin, the probability that head comes up when the coin is flipped equals the probability that tails comes up. So the outcomes are equally likely. So, consequently, when we assign the probability 1/2 to each of the two possible outcomes, that is P of H is equals to P of T is equals to 1/2. So for the bias coin, we have P of H is equals to 2 P of T, because P of H plus P of T is equals to 1. So it follows that 2 P of T and P of T is equals to 3 P of T is equals to 1. So we conclude that P of T is equals to 1/3 and P of H is equals to 2/3. So basic ano lang dyan, explanation is that syempre bias nga yung coin dun sa heads. So like mas double yung probability niyang lumabas kaysa sa tails. Kaya ayun. Kaya ganyan yung probability niya sa ano. So next, conditional probability. So it is defined as the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome. So we have an example for that. Please next po. So suppose that we flip a coin 3 times. So it is another coin flip game. So suppose that we flip a coin 3 times and all 8 possibilities are equally likely. Moreover, suppose we know that the event F, where the first flip comes up tails, occurs. Given this information, what is the probability of the event E that an odd number of tails appear? So ayun. Next po. So here's the solution. So because the first flip comes up as tails, there are only 4 possible outcomes, which is 3 tails, 2 tails and heads, tails, head, tails, and the last one is tails, heads, and heads. So where H and T represent head and tails and respectively. So an odd number of tails appear only for the outcomes of tails, and tails, head. So because the 8 outcomes have equal probability, each of the 4 possible outcomes, given that F occurs, should also have an equal probability of 1/4. So this only suggests that we should assign the probability of 2/4 is equals to 1/2 to E, given that F occurs. This probability is called the conditional probability. So next, independence. So what is independence in math? So it is a fundamental notion in probability theory, as in statistics and the theory of stochastic processes. 2 events are independent, statistically independent or stochastically independent if, informally speaking, the occurrence of one does not affect the probability of occurrence of the other, or equivalently does not affect the odds. Similarly, 2 random variables are independent if the realization of one does not affect the probability distribution of the other. So, ang pinaka-example lang about independence, nasa na siya, it's the word itself. Since there are 2 events and scenarios na dapat hindi maaapektuhan yung probability ng isa pag may changes or occurrence or disturbance something dun sa isang event. So kagaya nung sa Monty Hall 3-door puzzle, hindi siya pwede maging independent, hindi siya matatawag na independent since once na nag-open na ng door yung game show host, nagbabago na yung probability ng isang door, which is, ayun, naaapektuhan yung probability nila, which is hindi pwede maging independence. So, next. So to further understand that, we have this example. So suppose a coin is flipped 3 times. As described in the introduction to our discussion of conditional probability, thus knowing that the first flip comes up tails, alter the probability that tails come up an odd number of times. In other words, is it the case that P is equal to P of E? So this equality is valid for the events of E and F because P is equal to 1/2 and P of E is equal to 1/2. So because this equality holds, we say that E and F are independent events since hindi nga naaapektuhan yung dalawang events. So when 2 events are independent, the occurrence of one of the events gives no information about the probability that the other event occurs. So ayun. Next po. Next, we have the Bernoulli trials and binomial distribution. So, suppose that an experiment can only have 2 possible outcomes. So, syempre, ang dito ay yung flip coin and yung binary, which is 0 and 1. So, each performance of an experiment with 2 possible outcomes is called a Bernoulli, who made important contribution to probability theory. Next po. So, Bernoulli trials and binomial distribution. So, here's another meaning. In general, a possible outcome of a Bernoulli trial is called a success or failure since dalawa lang yung dapat na object or event na mangyayari. So, if P is the probability of success and Q is the probability of failure, it follows that P plus Q is equals to 1. Many problems can be solved by determining the probability of K successes when an experiment consists of N mutually independent Bernoulli trials. So, Bernoulli trials are mutually independent if the conditional probability of success on any given trial is P. So, given that information whatsoever about the outcomes of the other trials. So, to further understand this, we have example. So, a coin is biased so that the probability of heads is 2/3. So, napag-usapan na natin ito kanina. So, what is the probability that exactly 4 heads comes up when the coin is flipped 7 times? So, assuming that the flips are independent. So, next. Oh, here's the solution. So, there are 27 is equals to 128 possible outcomes when a coin is flipped 7 times. So, the number of ways 4 of the 7 flips can be heads is C, tapos ang laman niya is 7 and 4. So, because the 7 flips are independent, the probability of each of these outcomes, 4 head and 3 tails, is 2/3 and 1/3. So, consequently, the probability that exactly 4 head appear is C7, 4, 2/3, 1/3 is equals to 35, 16, 37 is equals to 56. Ayan. So, next po. Next, we have random variable. So, a random variable is a variable whose value is unknown. Siyempre, random nga. So, or a function that assign values to each of an experiment's outcome. A random variable is a function from the sample space of an experiment to the set of real number. That is, a random variable assigns a real number to each possible outcome. Next. So, to further understand with this, we have another example, which is another coin flip ulit. So, for instance, we may be interested in the total number of 1 bit in a randomly generated string of 10 bits. or in the number of times. Tails come up when a coin is flipped 20 times. So to study these types of problems, we introduce the concept of random variable. So suppose that a coin is flipped 3 times. Let x with a random variable that equals the number of heads that appear when t is the outcome. So then x of t takes on the following values, which is x and heads is equals to 3, x HHT is equals to x HTH is equals to THS is equals to 2, x TTH is equals to x THT is equals to x HTTN is equals to 1, and lastly x HTT is equals to 2. So next. So, ito tayo sa Monte Carlo algorithm. Since napag-usapan na natin to sa modeling simulation natin. So, Monte Carlo algorithm. So, the Monte Carlo method is defined as a statistical analysis based on artificially recreating a chance process with random numbers, repeating the chance process many times, and directly estimating the values of important parameters. So, bukod doon, a Monte Carlo algorithm is a type of resource-restricted algorithm that returns answer based on probability. As a result, the solution produced by the Monte Carlo algorithm may or may not be correct within a certain margin of error. So, mathematicians, scientists, and developers use Monte Carlo algorithms to make observation based on input. So, next. Lastly, in an introduction to discrete probability is a probabilistic method is a non-constructive method primarily used in combinatorics and pioneered by Paul Erdos for proving the existence of a prescribed kind of mathematical.
Hello? Ano po ka? Wait, rinig po ba? Okay. Hello, I'm Josh. And I will be reporting the part of Bayes' theorem. Right. Okay, next slide. Bayes' theorem. This is the formula for Bayes' theorem, in which P, A given B, the bar there is given, which it tells us the P, A given B, the probability that A is true, given that B is true, and P given A, given that the probability B is true, given that A is true, and the P of A is the probability that A is true, and the probability that B is true. And although in more practical use, you use the following formula, which is next slide please, which is the expanded form. This is what you commonly use more than the other formula, in which everything is the same, but the thing that got added was P given B, the probability of B given that not A, or the probability of B is true given that A is false, and the probability of A that is false. And then next slide please. Now, why use Bayes' theorem? It is to calculate the probability based on prior probabilities that were given, and it shouldn't determine your beliefs but update it. And in practice, it's applied but not limited to testing false positives, spam filters, the weather, and many more, as we see in the next few slides. Next slide, please. Right now, I have an example. A bag bag 1 contains 4 white and 6 black balls, while another bag number 2, contains 4 white and 3 black balls. One black ball is drawn at random from one of the bags, and it is found to be black. And here we have to find the probability that it was drawn from bag 1. Next slide. Now, here are the formula, which is 0.5 multiplied to 0.6 all over 0.5 multiplied to 0.6 plus 0.5 multiplied to 0.43. Simplifying the formula first, we can get the answer being 0.58 or approximately 58%. Now, as to how I got the numbers is for the next slide. Here are the numbers for the next slide, and each color represents what the numbers are. Next slide. Here's our second example, a much more realistic example. Right? It says that suppose that 1 in 100,000 person has a particular rare disease in which it's a fairly accurate diagnostic test. This test is correct 99% of the time when given to a person selected at random who has the disease, and it is correct 99.5% of the time when given to a person selected at random who does not have the disease. Given this information, can we find the probability that a person who tests negative for the disease does not have the disease? In simple terms, it's testing whether if they tested positive, it's actually positive, and if they tested negative, it's actually negative. Right. Next slide, please. Here's your formulas. Now we're finding whether if they're negative, if they tested negative, they're actually negative, and it says here that the percentage that they're actually not it's not a false positive is 99%. So the test is 99% accurate if they're actually tested negative. Next slide. And here's a breakdown of our second answer. Right, each color responds to where I got it from. And then next slide. And now we turn to the expected value. Next slide. The sum over all elements in a sample space of the product of the probability of the element and the value of the random variable at this element. The expected value of a random variable provides a central point for the distribution of values of random variables. Next slide. And here is the formula for the expected value, in which this is the summation of g of x and multiply it to its probability. Next slide. Here's our example. Let x be the number that comes up when a fair die is rolled. What is the expected value of x? Next slide. And here we have the answer. E of x, which is the summation of x, is basically 1/6, which is the probability a certain dice roll, multiplied to 1, which is the how many times it got, or the n. And then we add all of them up so we get the summation of x, which is 21 over 6 is equal to 7 over 2. Right? Next slide. The next is the variance. The expected value of a random variable tells us its average value, but nothing about how widely the values are distributed. Provides a measure of how widely a variable is distributed about its expected value. Next slide, Pop. In here, we have the summation again, but this time, instead of only the function of x, we multiply it to the mean we got back then, which is 7 over 2 squared, plus its probability again. Yes. And then next slide, please. And using the example below, if we use the example from earlier, we can conclude that e of x squared is 1/6 plus 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. The reason we did this is we can just factor up 1/6, if I recall correctly, and then just add all of them up. And finding the variance is simply doing the first part since we factored it out, and squaring our mu, and we get the variance, or how common it appears, is 35 over 12. And next slide.
Good morning. Rinig po. Applications of recurrence relation. A recurrence relation is an equation that recursively defines a sequence where the next term is a function of the previous terms. Initial conditions are required to define terms that precede the first term where the recurrence takes effect. So yung recurrence relations, need yan ng mga initial values para ma-determine kung ano yung value na yung next na value according dun sa equation or yung sequence na given. Next slide. So, we have a problem. Suppose that the number of bacteria in a colony doubles every hour. If a colony begins with 5 bacteria, how many will be present in n hours? So, yung given natin, meron tayong 5 bacteria. Tapos sabi, every 2 hours, every hour nagdo-double yung value niya. So, yun yung initial value natin. Itong a sub 0 is equals to 5. So, sa next r, a1, magiging 2 times 5 kasi magdo-double nga daw. So, magiging 10. Tapos, sa a2, ito times 2 ulit natin yung value ng a1 sa 2, which is, 20. So, ayun. Yung answer natin is magiging 2an minus 1. So, bakit? Kasi nga, yung an minus 1, yun yung value before. So, yun na yung 2, yun yung double every hour. Tapos yung an minus 1, yun yung value. Tapos, pag makikita natin later sa mga slides, merong laging mga an minus 1 or n minus 1. Basta pag may ganon, ang meaning nun is yung value niya before. Meron din tayong n minus 2. Ang ibig sabihin naman nun, kapag n minus 2, yung before na itong a1, so a0, yun naman yun. Parang dalawang steps. Next slide. Modeling with recurrence relations. We can use recurrence relations to model a wide variety of problems such as finding compound interest, counting rabbits on an island, determining the number of moves in the tower of a Hanoi puzzle, and counting bit strings with certain properties. Next. So, first example, rabbits and Fibonacci numbers. A young pair of rabbits, one of each sex, is placed on an island. A pair of rabbits does not breed until they are 2 months old. After they are 2 months old, each pair of rabbits produces another pair each month, as shown in figure 1, which is nasa next slide. Find the recurrence relation for the number of pairs of rabbits on the island after n months, assuming that no rabbits ever die. So, next slide. So, ayun. Meron na tayong isang pair ng rabbits. So, after 2 months pa siya mag-breed. So, sa month 2, makikita nyo, wala pa rin siyang breed kasi nga, next month pa. So, ayun, reproducing pairs na siya sa 3rd month. Tapos, may na-reproduce na siya na isang pair. Tapos, sa 4th month, dalawa pa din kasi nga, etong nasa 3rd month na yung pairs, hindi pa rin siya pwedeng mag-breed. So, nag-reproduce ulit sila na isa, kaya naging dalawa. Then, after, sa 5 months, dalawa na, kasi yung una nilang binreed ay pwede na mag-reproduce. So, yung kaninang before sa 4th month, na 1st month na rabbits, ayun yung isa doon. Tapos, yung dalawang na-reproduce netong dalawang pair, kaya naging 3 yung young pairs. Sa 6th month, yung first month kanina, dito sa, tawag net, sa 4, ay sa 5, 2 months na siya, so pwede na siya mag-breed, tapos, 3 na yung reproducing pairs natin. So, yung dalawa kaninang na-reproduce sa month 5, andito na siya sa month 6. Tapos, magre-reproduce ulit tong 3 pairs natin. So, kung titignan natin yung total pairs, meron tayong 1, 1, 2, 3, 5, and 8. So, ano mapapansin natin? Parang meron siyang sequence. Bakit masabing meron siyang sequence? Kasi, pag tinignan nyo siya, 1 plus 1 is equals to 2, 2 plus 1 is equals to 3, and 3 plus 2 is equals to 5. And so on and so forth. Kaya naging 8. Tapos, next slide. Next slide po.
Next slide daw.
Next slide po, Rabi.
Rabi.
Ay,
Ezra.
naka-freeze daw po, ma'am.
Naka-freeze?
Oh.
Eh di unfreeze. Hindi, joke lang. Fibonacci. Ayan. Okay, and then next. Ayan.
So, ayan. Yan yung equation natin for Fibonacci. So, itong Fn minus 1, yung sinabi ko nga kanina, ito yung value nun. Kunwari, dito, 2 yung initial value natin. Tapos, plus natin siya sa value before that. So, 1. So, 2 plus 1 is equals to 3. So, ayan na. Next. So, next example is the Tower of Hanoi puzzle, a popular puzzle of the late 19th century invented by the French mathematician Edward Lucas called the Tower of Hanoi. Consists of 3 pegs mounted on a board together with discs of different sizes. Initially, these discs are placed on the first peg in order of size, with the largest on the bottom. The rules of the puzzle allow discs to be moved one at a time from one peg to another as long as a disc is never placed on top of a smaller disc. The goal of the puzzle is to have all the discs on the second peg in order of size, with the largest on the bottom. Next slide. So, ito siya. So, baka yung iba familiar na dito. So, ang pinaka-goal nito is, yung rules muna is, one at a time lang siya. So, hindi ka pwedeng kumuha ng 2 discs to transfer mo sa next peg. Hindi pwede yan. So, dapat isa lang. Tapos, hindi rin pwede yung bigger disc ay papatong mo dun sa smaller disc. Tapos, ang pinaka-goal niya is, kailangan malipat mo silang lahat, katulad dito sa figure 2, sa next peg. Kailangan malipat mo sila lahat ng, while following the rules. Tapos, dapat yung bigger disc, yung nasa pinaka-ilalim, yun yung, sa next figure, nandun pa rin siya sa ilalim. So, next. So, paano natin makakount yung moves nung, yung need nating moves for, the tower. So, etong 2hn minus 1 represents yan yung moves, bawat moves ng isang disc. So, for example, meron tayong 2 disc. So, yung 2 disc na yun, ito, so next, yung 2hn minus 2 plus 1, ayan yun. So, bali magiging, yung pinaka-equation niyan, ito talaga, yung 2n minus 1. So, parang, itong, nasa taas niya, ano lang yan, tawag na to. Parang, para mag-give, para malaman nyo kung saan nanggaling yung 2n minus 1. So, etong n, ito yung, kunwari, ilang disk yung nasa kabilang slide kanina, meron tayong 6. So, 6 times 2, ay 2 times 6. So, 2 raised to 6 is meron tayong meron tayong 64 minus 1. So, magkakaroon tayo ng 63 moves. Need natin ng 63 moves para ma-transfer yung 6 na disk to another peg. So, ayun. Next slide.
6 na disk. Oh, maraming moves nga yun.
So, ito. A myth created to accompany the puzzle tells of a tower in Hanoi where monks are transferring 64 gold discs from one peg to another.
Wait lang, bago ka pumunta dyan. Bigay mo sa amin yung solution dun sa sa Hanoi Tower, dun sa
Ay, pabalik po.
Oo, para makita natin yung So, yung 2-1N, so paano siya ginawa na malipat ng following the rules?
Ayun lang po. Ito nga pong 2HN plus 1. So, kunwari, 2HN plus 1, ito yung pinaka-initial niya. Tapos, kunwari, kung may mga iterations pa po kasi yan. So, parang, sa next iteration, para po makuha mo yung, kunwari, sa 2 disk po, sa next value niya, magta-times ka po ulit ng 2, tapos ay 2, ta-times mo dito sa HN minus 1. Ito, yung una na pong 2HN plus 1, yun na po yung magiging value ng HN.
Okay.
Kaya po, yung 2 times 2HN minus 2 na plus 1. Tapos parang pinaka-simplification niya na lang po 2N minus 1. So, ito pong mga pinaka-una niya, yung parang pinaka-iteration. Para lang po maiwasan natin na mag-iterate, lalo pag marami po tayong kailang i-count na disk.
Okay, sige. Gets ko. Sige.
Next slide. So, wait lang. Balik
Balik
ka
dun sa Hanoi Tower. Yan.
Ayan. Transferring 64 gold disc from one peg to another, according to the rules of the puzzle. The myth says that the world will end when they finish the puzzle. How long after the monks started will the world end if the monks take 1 second to move a disc? From the explicit formula the monks require, ayan po, yung 2n minus 1. So, meron sila kasing 64 gold disc as stated. So, ito yung pinaka-calculation niya. So, ayun. Making 1 move per second, it will take them more than 500 billion years to complete the transfer. So, the world should survive a while longer than it already has.
5, 6, 7.
Ayun. Next.
Wag umalipat, sandali, binibilang ko lang. So, million, billion, trillion, quadrillion. Mahaba, marami itong combination, yung 64. Hindi lang quadrillion
kaya
pa
po,
nga siya.
yun po yung ginagamit na equation. Para po, kasi kapag minano-mano po yan, parang impossible, parang hindi man impossible, pero tiresome po pag kinompute natin, pag paulit-ulit na iteration.
Okay. Okay, gets. Yeah. Sige. So, mas mahirap talagang manalo ng loto dun sa 64. Ito nga lang ay times pa siya sa 2. So, mas marami
Next
yung combination.
Okay na po.
Sige, go. Yung teacher nyo kasi nag-iisip ng Ito mo yun. Mataas kasi yung possibility para since pinag-uusapan natin itong mga puzzle na to. I don't know if you were able to watch yung
papalit po ng presenter.
Sige, palit ng presenter. Habang nagpapalit kayo ng presenter, magpapatalastas lang ako. Patalastas kwento. Diba kung yung napanood nyo yung mga wizard ng na movie na ano bang eskwelahan yun sa US, pero that's a true story, no? Mga genius, no? Mga genius sa math at mga programmer din. ito yung subject nila ng mga analysis and mga combination statistics, no? Sa Harvard ata yun, yung mga estudyante na yun. So, hinak nila kung paano mananalo dun sa mga nagbebet, ano ang tawag doon? Sa kasa. Actually, bawal na silang pumasok ngayon dahil yung mga mukha nila sa ulado na. Kumbaga, binibit nila yung odds dun sa manalo, halimbawa dun sa card game, ganon. So, pinondohan sila ng isang business person dun sa Tapos, nag-extra sila. Tapos, mga bata pa yung mga kasing edad nyo, college students, na trinay ng mga professor with yun nga, yun sa discrete na mga theorems, mga probabilities, ayan. So, nabit nila yung odds dun sa para manalo dun sa mga card games. Hanggang sa nanalo na sila ng milyon-milyon. Tapos, nag-iiba sila ng The Disguise. I forgot what's the name of that movie. But, simply put, pwede mo rin gawin yun sa loto. Actually, marami nang nag-try i-beat yung mga mathematician na i-try i-beat yung loto. Meron kang pwedeng bayaran na bibigyan ka ng halimbawa combinations lang, kaya lang kailangan mong pondohan like 500,000, pero gagawin mo yon halimbawa na so may 500,000 ka, ibibit mo yung odds, tumempo ka na mataas yung output ng ng loto para yung yung combinations mo at least may pumasok, no? Mababawi mo yung pondo mo. Ayan. Okay, sige, go. Wala lang. Nagpatalastas lang ako.
Dynamic programming. A computer programming technique where an algorithmic problem is first broken down into sub-problems, the results are saved, and then the sub-problems are optimized to find the overall solution, which usually has to do with finding the maximum and minimum range of the algorithmic theory. So, yung pinaka-goal nitong dynamic programming is maiwasan natin yung paulit-ulit na kunwari, like, dito sa figure, yung, kunwari, itong F18, na-compute ulit siya dito sa right. So, iiwasan natin yun by doing dynamic programming. Basically, ang gagawin niya is like, itong F18, sasave niya yung parang computation na to para magamit niya sa overall solution nung program na ginagawa. So, ayun. Next slide. Solving linear recurrence relations. A linear homogeneous recurrence relation of degree k with constant coefficients is a recurrence relation of the form ito, an hanggang ckn minus k, where c1, c2, ck are real numbers and ck must not be equal to 0. So ito, may dalawang type ng linear recurrence. Yung isa is homogeneous and yung isa non-homogeneous. So, para malaman natin yun, basically, dapat yung equation, pag merong fn is non-homogeneous siya. Tapos kapag wala naman siyang fn, yung fn kasi parang hindi siya constant yung fn. So parang basta may given, tapos may hindi magagamit yung previous value niya. Basta next slide. So ayan, solving linear homogeneous recurrence relations with constant coefficient. So ipiprove natin na itong 2 raised to n is a solution of this 2a n minus 1. So tignan natin yung values sa table. Makikita nyo na parang lang siya, dinodoble lang yung value sa mga next value niya. Tapos, kunwari dito, sa 2an, ay sa 2n, ang n natin dyan is andito sa left side. So, kaya ganyan yung values. Pag ginamit mo tong 2an minus 1, Itong an minus 1, ito yung previous value niya. Yung kunwari, 2 times 2. Kunwari dito sa n1, 2. Tapos, ang magiging sagot ng n2 is 4. So, itong tatlo na to is a solution to 2an minus 1. So, ayan. Next slide. So, ito naman, ano rin to, homogeneous. Solve the relation an is equals to 5an minus 1 minus 6an minus 2. So, bakit naging r squared? Kasi gumamit tayo ng characteristic algebra according dun sa book. Tapos, nalis lang natin itong 1 tsaka 0 kasi ganun pa rin naman siya. Tapos, inequate natin siya to 0. And then, after that, finactor natin. Tapos, nagkaroon tayo ng, zero product property. Kaya, r is equals to 2 and r is equals to 3. So, from that, makakonclude natin na an is equals to 2n and an is equals to 3n. So, pakita natin sa next slide. So, ayan. Kapag ginamit natin itong 2n, 3n, and i-compare natin dito sa relation, magkakaroon pa rin tayo ng mga nakuha nating values dito is makukuha pa rin natin. So, ganun. Next slide. So, dito naman tayo sa non-homogeneous. Solving linear non-homogeneous recurrence relations with constant coefficients. So, ito yung pinaka, syntax. Ito, meron siyang fn sa dulo. Kasi kanina wala. Yun yung sasabi kong function. Kunwari dito sa example, meron siyang, example is equals to 3an minus 1 plus 2n. Etong 2n, kapag, ayan yung nagdi-distinct sa kanya from being homogeneous. Pero itong 3an minus 1, kung wala yung 2n, masabi mong homogeneous siya. So, ayan, ang initial value natin is 3. So, tignan natin sa next slide. Paano natin i-solve? Ayan. To solve a non-homogeneous recurrence relation, we must solve the associated homogeneous recurrence relation denoted A, Hn. In addition, we must solve for the particular solution of the homogeneous recurrence relation denoted Apn. For this, we will guess the form of Apn based on the function of n. So, dito, mag-guess tayo. Dito tayo kukuha ng guess sa may Apn. Yung Fn kasi, yun yung hulaan natin kung ano yung magiging value niya. Tapos, andito sa Apn, yung uhulaan nating mga value. So, tingnan natin sa next slide. So, ito yung pinaka-equation natin for non-homogeneous. So, kailangan muna nating, itong AHN, ito yung, homogeneous side nung right-hand side ng equation. Tapos, itong APN, ito yung kanina, yung dun tayo magbabase ng APN, dun sa table na yun. Next slide. So, ito, pagpasensya nyo na lang yung sulat. Find all the solutions of the recurrence relations. An is equals to 3a, n minus 1 plus 2n, a1 is equals to 3. So, ito pa rin yung kanina nakalagay na example. So, isa-solve na natin siya. So, ito daw yung sequence niya, 3, 13, 45, at saka 153. So, first, kailangan natin kunin yung AHN. So, an minus 3, an1, ito yung ito yung given na equation, and equate natin to 0. Tapos gumamit ulit tayo ng characteristic algebra, kaya naging 3 minus 3, r minus 3 is equals to 0. Tapos ayan, r is equals to 3. So itong a3 is from ditong equation, two real identical roots form. So wala naman siyang like pangalawang r, so hindi na tayo gumamit ng b. Next. And then, after that, ayun, solve na natin yung APN. So, dito, gumamit tayo ng Cn plus D, galing dun sa table. Tapos, ayun, an minus 3, an minus 1, minus 2n is equals to 0. In-equate ulit natin yung given na equation. And then, after that, pinalitan natin yung given na an, pinalitan natin ng Cn plus D. Kaya naging ganito yung itsura niya sa next. Tapos, after that, pinagsama-sama natin yung Cn, yung mga Cn tsaka D. Tapos, And then, saka natin finactor para makuha natin yung C. At, masolve natin yung minus 2D plus 3C dito sa baba. Tapos, mayroon na tayong answer sa A and P. So, ano naman next? So, next natin is solve na natin yung AN. And then, nag-substitute na tayo na yung kaninang sinagutan natin na ANH, which is, ang sagot is A3N. Ayan, sinubstitute na natin dito sa right. And then, pati yung nakuha nating ANP. And then, ito naman, A1 is equals to 3 is equals to A times 3, 1 minus 3 halves. So, ayun, ito yung A1 natin. Tapos, parang, ano lang natin to. Isa-solve natin yung A dito sa equation na to. Kaya nag-arrive tayo sa sagot na 11 over 6, 3n minus 3 halves. So, next. Ay, wait lang. Paano, pwede ba mag-annotate, ma'am?
Pwede ba?
Hindi ko po alam kung pwede mag-annotate po.
Check mo. Ano bang ilalagay mo? Describe mo na lang kung hindi mapwede.
Ano lang po. Bali, iti-check lang po natin if yung itong nakuha po nating sagot sa AN is tama po. And makukuha ba natin yung mga sagot na binigay dun sa sequence. Parang checking lang naman po.
Okay.
Kaso wala po yung tama. So, ayan. Next slide.
Okay, so let's now proceed to the next topic, divide and conquer algorithms and recurrence relations. Generally, recursive is defined as an action with many executions. And when this concept is applied in different computing applications, it makes the algorithm powerful and it increases its efficiency if it is used properly. And when we apply this to a paradigm called divide and conquer, it becomes way more powerful. Next slide, please. In simple definition, divide and conquer means that we will divide the problem into one or more instances of the same problem of a smaller size. And then, they conquer the problem by using the solutions of the smaller problems to find a solution of the original problem. And perhaps adding some additional work. So, let's read the description sa PowerPoint. Divide and conquer means that you will divide the problem into one or more instances of the same problem. So, you will divide the problem hanggang sa maging single element na lang siya. That is the smallest division ng problem. And then, kapag na-reach na natin yung single element na yon, saka na natin siya i-conquer by, let's say, combining all the single elements hanggang ma-form ulit siya into one element. Next slide. Balik ka, isa pa. Ayan, yan. Okay, so many recursive algorithms takes a problem with a given input and divide it into one more or link smaller problems. This reduction is successfully applied until the solution of the smaller problems can be found quickly. So in the following slide, we will discuss the application of this concept on certain problems such as binary search, sorting algorithms, etc. So we have here the first sorting algorithm, which is the merge sort. Merge sort is defined as a sorting algorithm that works by dividing an array into smaller sub-arrays. So, ikakopy mo yung original array mo, gagawa ka ng temporary array, and then dun sa temporary array na yun, nandun yung smaller sub-arrays mo. Once we have the smaller sub-arrays, we will sort each sub-array, and then the merging will happen. So think of it as a recursive algorithm that continuously splits the array in half until it cannot be further divided. As I've explained earlier, i-divide natin siya in half until one element na lang yung matira. And kapag one element na lang natitira, the dividing will stop, which means the recursion will stop. Then we will invoke the sorting process on each individual elements. And once sorted, all the elements will merge. So next slide. Here we can see the visualization of the merge sort. The first part, ayan, makikita natin yung list of integers natin. Nasa isang list siya. This is the divide and conquer in merge sort algorithm. Kapag may list na tayo, hanapin natin yung middle element niya. In this case, ang middle element natin is 24. But since hindi naman siya pwedeng ihati dyan, hatiin siya between 24 and 46. After that, we have now two sub-arrays. Hatiin pa ulit siya since hindi pa siya single element. Ngayon, mahati naman yung first sub-array natin, yung nasa left, sa gitna. So, ang mangyayari, magkakaroon ng 11, 6, tsaka 3, 24. Yung nasa right array naman, mangyayari dito, mahalo siya sa 22 and 7. So, we have 46, 22, tsaka 7. After that, since tigdadalawa na lang sila, except sa 7 na isang element na lang, mahati pa sila ng isang beses. Hanggang sa ma-reach natin yung magkakahiwalay na elements na 11, 6, 3, 24, 46, 22, 7. Next slide. Now, this is the conquer in divide and conquer. Kapag nahati natin sila into single elements, magko-conduct na tayo ng sorting doon. So, nakita natin na dito sa starting from the left, ayan, starting from the left, pinagbaliktad yung 6 and 11 because 6 is smaller than 11. Then, starting from the right, then the next two sub-arrays, yung 3 and 24, nag-retain lang sila since sorted naman na silang dalawa. Sunod, 46 and 22, pinagbaliktad din since ganun yung arrangement nila. Then 7, niretain na 7. So, susunod naman na line, nag-combine na yung 6, 11, 3, 24, 22, 46, tsaka 7. And after that, pinag-merge ulit natin yung dalawang sub-array na yun. Pero this time, nakasort na siya into one sub-array pa ulit. Hindi pa siya main array. So, we have 3, 6, 11, 24 para sa left sub-array. And then, sa other side, we have 7, 22, 46. After that, the last merging happened. Ayan, we now have one single array na naka-merge sila ascending. Next slide. So we have the following pros and cons for merge sort. First is the pros of merge or the advantages of merge sort. Merge sort has a time complexity of O n log n, big O n log n notation, which means that it is relatively efficient for sorting large data sets. Next, we know that merge sort is a stable sort, which means that the order of elements with equal values are preserved during the sort. Next, it is easy to implement. Therefore, it is a good choice for many applications. Also, it is useful for external sorting. This is because merge sort can handle large data sets since meron nga siyang time complexity of O and big O and log n. It is often used for external sorting where the data being sorted does not really fit the memory. Next is merge sort only needs a few additional resources, typo error po yan, such as memory to perform the sort. This makes it a good choice for the system lalo na kapag yung system mo ay may limited resources. Pero, despite that, we also have the cons or the drawbacks of merge sort. It is slower compared to other sorting algorithms for smaller tasks because mas efficient nga siya for larger data sets. So, hindi siya best choice for smaller data sets. The merge sort algorithm requires an additional memory space of O(n) for the temporary array. para may mapag-i-storan yung sub-arrays natin na ginamit natin during the sorting process. Another is, it goes through the whole process kahit na sorted na yung array. So, let's say na onti lang yung datasets mo. So, onti lang siyang best pwede divide. So, even if sorted na siya, during those few times na dinivide siya, magkukontinue pa rin siya. So, that is one of the drawbacks. And lastly, it requires more code to implement since nag-divide nga ng smaller array. And nagmo-merge siya pabalik sa isang array. Next slide. So here is another example for divide and conquer with recurrence relations. The binary search tree. Wait lang po. Okay. So for the binary search tree, medyo similar siya sa merge sort algorithm natin. Pero, dito, hindi na siya mag-merge pabalik. Kasi, naghahanap lang tayo ng specific number sa list of integers natin. So, meron tayong list of integers dito. And then, as I mentioned earlier, divide and conquer means that you have to divide it in half until one element is left. So, di-divide natin yung list natin sa gitna. So, dito ang hinahanap natin is number 11. So, once na-divide natin sa gitna, hanapin natin kung aling side ba malapit yung 11. So, we can notice that this list is arranged ascendingly. So, malalaman natin na sa left side pala yung 11 kasi ascending siya. So, sa left side, mahati ulit sa gitna yung sub-array natin. And then, i-test ulit natin kung nasan ba yung 11 dito. Is the middle element greater than or less than 11? Siyempre, kapag greater than, makikita natin yung 11 sa right side. So now, kapag nakita natin kapag nahatian natin yung right side, hatiin ulit natin sa gitna yung natira. So now, mag-a-arrive tayo sa hinahanap natin number. Next slide. So those were the examples of how divide and conquer with recurrence relation can be applied to different algorithms, useful algorithms actually, na pwede natin magamit sa mga future programs natin. And next, we have this master theorem. Hindi ko na masyadong bibigyan to ng definition, dadaanan ko na lang. Because master theorem is basically used to determine the running time of algorithms. Yung binabanggit ko kanina na time complexity, yun. So, ginagamit to para malaman yung running time ng algorithms during their asymptotic behavior. In the next slide. Next slide. Yan. We can see yung formula na ginagamit para ma-determine kung ano yung time of algorithms for our algorithms. So, yan. We have T of Tn is equals to A Tn over B plus F. And where N is the size of the problem, and A is equals to the number of sub-problems in the recursion, and A is greater than or equal to 1. Now, N over B is equal to size of each sub-problem, and F of Fn is equals to the cost of work done outside the recursive calls. Okay, so next slide. Now, let's proceed sa generating functions natin. Wait lang po, ma'am. So, when we say generating functions, this is an extremely powerful tool in discrete structures that's used to manipulate sequence called a generating series. It is a way to encode an infinite sequence of numbers by treating them as the coefficient of a formal power series. So, may example ako ng sequence dito sa baba. It is an infinite, kaya meron siyang ellipse sa dulo. So, hindi pa dito, from the sequence,
hindi natin ma-determine kung ano yung next value niya. But we can use the generating functions to determine kung ano yung magiging next values nila. Next slide. Isa pa. Ayan. So, ito yung sequence natin kanina, 3, 0, 8, 1, and 1/7, 100, ... And ito yung generating series natin, kung saan matatrack natin kung pang ilang number na yung number na yon sa series natin. So, we can see na yung 100 is a 6th term in this series kasi meron siyang x to the power of 6. So, we can look at a single function which encodes the sequence, but not a function which gives the nth term as the output. Just like yung formula ng Fibonacci sequence, wherein kailangan mo ng n para malaman yung, kasi kailangan mo ng previous term and the current term, so kailangan mo ng n para malaman kung ano yung previous term and current term. For generating functions, hindi kailangan na ganun. You can just look at a single function para makita mo yung susunod na number in the sequence. So, okay, next slide. So, we write a power series like this. This is the summation of c sub k x raised to k as k progresses to infinite. So, ayan. Tama. Let's try to see kung paano tayo nag-arrive sa sequence natin kanina and generating series natin kanina. Ito yung example ko kanina sa previous slide. So, makikita natin dito from the generating series, we can observe na kinukuha lang natin yung coefficient of each term para makuha natin yung integers nila sa series. So, pag nakuha natin yung coefficient, iiwan natin yung x raised to the power of n. So, in this case, we have 3 as the first number in the sequence, since wala siyang yung x na yun walang wait lang, sorry, nawawala ako. Wala siyang power na naka-raise, and the following number we have 8x squared. So wala tayong x lang. Since wala tayong x lang, naglagay na lang tayo ng 0. And then, kinuha natin yung 8 as the coefficient para ilagay sa series natin. And 1, since wala tong coefficient. And so on and so forth. So, next slide. Ito, here's another example para mas makuha natin kung paano sinusolve yung generating sequence. Ayan. We have the given sequence 1, 1, 1, 1. So, by the looks of it, parang madali lang siya. Pero, we have the generating series is 1 plus x squared plus x cubed plus x raised to the power 4 plus. Next slide.
Ganun tubig. Tubig.
Okay, let's see what the generating function for the very simple sequence. So, nakita natin kung ano yung sequence natin, and nakita natin kung ano yung generating series. Now, we can find a closed formula for this power series. So, this is a particular series. It's really just a geometric sequence with common ratio x. So, if we use other techniques, such as this, yung s sa taas, s equals to 1 plus x squared plus x cubed, and so on. This is the first series. And yung nasa baba niya, negative minus x, s equals to x plus x squared plus x cubed plus x raised to the 4th power, so on. This is the next element in the series. Kaya naman, yung naging equivalent ng dalawa is 1 minus x, which refers which refers to the next element in the series, equals to 1. So if we go to the next slide please. Ayan, may kita natin na kapag manipulate natin yung result ng konti, result kanina, yung 1 minus x, s equals to 1, kapag in-isolate natin yung x, we can see that the sequence equated to 1 over 1 minus x. Therefore, this is the generating function for the series. Next slide. Ayan, so these are some useful generating functions. Bale, kapag mag-solve ka ng generating functions, pwede ka mag-base sa mga paratong theorems and such na pwede mong pag-basean kapag nag-solve ka ng generating function para makapag-arrive sa answer mo. So, meron to sa libre natin. Kinuha ko lang to doon.
Formula.
Yes po.
Okay.
Okay, next slide. Now, let's try another example naman. Yung previous example natin, wala pa tayong ginagamit na summation. Pero for this one kasi, this contains recurrence relation na. So, gagamit na tayo ng execution na repeating. Kaya gagamit na tayo ng summation. And hindi na tayo mag-arrive sa exact value katulad ng kanina na may 1 over 1 minus x. This we will arrive at an estimation na lang. So, let's solve the recurrence relation A, that is sub k, equals to 3a sub k minus 1, for k is equals to 1, 2, 3. So, ito yung answer natin. G of x equals to summation of a sub k x raised to k as k approaches infinity. Next slide. Ayan, before arriving to that answer, parang himayin muna natin siya. We have here the generating function for the sequence. Let's note that g of x is equals to summation of a sub k, x raised to k plus 1 as k, that is equal to summation of a sub k minus 1, x raised to k as k equals 1 approaching infinity. In the next slide please. Ayan. Yung pinakita ko kaninang formula, para siyang base formula natin. So, doon tayo magsisimula. May kita natin dito sa susunod na formula natin. Naglagay na tayo ng substitute for the x. So, x is equals to gx minus negative 3x, which is yung given kanina. So, that is equals to the same formula kanina. Pero this time, nung sinolve natin siya, we arrived at the a0, which is equals to 2. So, because a sub 0 is equals to 2, and a sub k is equals to 3a, k minus 3a sub k minus 1, yan yung given kanina. Thus, we can conclude that g of x minus 3x, g of x is equals to 1 minus 3x, g of x is equals to 2. Pero hindi pa yan yung final answer. If we proceed to the next slide, ito yung sinasabi ko kanina, we can base off dun sa table natin. Meron dong mga base para formula na pwede natin gamitin as we conclude yung mga sinasolve natin. We base natin siya dito sa identity formula na to. G of x is equals to 2 summation of 3k xk as k equals 0 approaches infinity. And that is equals to summation of 2 times 3 raised to k x raised to k as k approaches 0 up to infinity. And consequently, a sub k is equals to 2 times 3k. So that is all for the divide and conquer recurrence relation and generating functions using recurrence relation. Now we will proceed to our next topic, which will be discussed by Rabbit. Thank you.
Okay.
Okay, so for the
principle of inclusion and exclusion. So, this is in context with set. So, pag nakaka-encounter tayo ng word problems in terms of set, meron doon lagi yung exclude yung ganito, include yung unions and intersections. So, yung solving nun, yun yung i-discuss mo. For example, in the estate had 64 homes for sale, have garages, 21 have pools, and 17 have both a garage and a pool. How many total homes are for sale? So, normally, pag nakaka-encounter tayo ng ganitong problem, ang una natin ginagawa is maggawa ng Venn diagram and then i-plot lahat ng given, which is tama naman. And then, from that, dun tayo gagawa ng technique to solve yung question. So, kagaya dito, hindi naman pwedeng i-add lang kasi nadodoble yung intersection. So, ang solving dito is 64 minus 17 equals 47. Yun lang yung home na may garage. And then 21 minus 17 equals 4. Yun lang yung home with pools. And then 17, yung intersection. Yun lang talaga yung homes with pool and garage. So, dun pa lang makakapag-add para makuha yung sagot dito sa question na to. So, there's actually a way para hindi na laging mag-Venn diagram, which is next slide. And so, principle of inclusion and exclusion. So, it is a counting technique that computes the number of elements that satisfy at least one of several properties while guaranteeing that elements that satisfy more than one property are not counted twice. So, kagaya kanina dun sa previous example, nag-minus-minus muna bago mag-add para hindi madoble yung bilang. So, the underlying idea behind this principle is that summing the number of elements satisfy at least one of two categories and subtracting the overlap prevents double counting. So for instance, the number of people that have at least one cat or at least one dog can be found by taking the number of people who own a cat, adding the number of people that have a dog, then subtracting the number of people who have both. Next slide. Principle of inclusion and exclusion. The number of elements in the union of two finite sets A and B can be modeled by cardinality of A union B as cardinality of A plus cardinality of B minus A union B. So, dito sa formula na to, binaynos yung intersections nila para hindi ma-double count yung intersection. And then yung cardinality yung A, so yun yung sa A, and then cardinality ng B, yun ang yun sa B. For example, kagaya ng problem kanina. This time naman, kagaya ng Venn diagram save na time. So, in the real estate, 64 homes per sale have garages, 21 have pools, and 17 have both a garage and a pool. How many total homes are for sale? So, ilalet lang at itong mga given. So, yun ng A and B yung total homes for sale. Cardinality ng A yung homes with garage. And cardinality ng B yung homes with pool. So, A intersection B yung homes with both garage and pool. So, substitute lang from the formula yung mga given and then mag-a-arrive lang sa 68 total homes, which is same lang sagot dun sa unang example. Next slide. Okay, another example is if there are only computer science and math major in discrete math, then there are 42 computer science majors, 15 math majors, and 8 students who are double majors. How many students are enrolled in discrete math? So, same technique as kanina. Cardinality ng A union B, yun yung students enrolled in discrete math. Cardinality ng A, yun yung computer science major students. Cardinality ng B, yung math major students. And cardinality ng A, intersection B, yun yung double major students. So, using the same formula, substitute lang, and then the answer would be 14 total students.
Okay, so for the three sets naman, so the number of elements in the union of three finite sets A and B can be modeled by cardinality ng A union B. Union C equals cardinality ng A plus cardinality ng B plus cardinality ng C minus sum ng A intersection B, A intersection C, B intersection C plus A union B, A intersection B intersection C. So different from formula ng dalawang sets lang dito, may in-add back which is yung A intersection B intersection C. Kasi yung, di ba pag nag-minus na, dito sa tatlong minus na to, pag minus na siya, hindi na makakount yung pinaka-intersection ng tatlong set. So that's why, mag-add back para makount yung nasa gitna. Next. Okay, example, there are 150 odd dots and 3 pure bands A, B, and C. So 58 yung sa A brand, 49 yung sa B brand, 57 yung sa C brand, 13 yung A and B, 14 yung A and C, 17 yung B and C, and 4 yung A, B, C. So how many adults take lang? So, ang given dito is yung total. Okay. And so to stop that, same thing, ulit lang yung A, union B, union C, mga adults who different A, B, and C, cardinality ng A, yung 58, yung B, yung 49, yung 57, and then yung mga intersection B, 13, A intersection C, equals 40, intersection C equals 17, and then yung mga intersection nila, 4. So, calculating all that, so, since may given naman kami na 150, which is yung total, so after makuha yung mga total ng adults na umiinom ng drink, minus lang sa nakuha ang sagot, so ang magiging final answer dito is 26. Yun yung mga adults who drinks lang. So, next slide. Okay, with all that formula and examples, so pwedeng mag-create ng generalized na formula for all sets. So, ito na yun. A sub 1, union A sub 2 to union ng A sub 10 is equal to summation ng mga sets minus yung intersection nila plus yung pinaka-intersection ng totality ng set. So, itong formula na to, as what you can see, meron yung natin less than equals I, less than equals S. So, nag-expand siya or nababawasan yung terms depende kung gaano kadaming sets yung given and kung saan siya apply. So, example, next one. Okay, so, meron 200 students, yung 64 like sprouts, 94 in broccoli, 58 like cauliflower, 26 bowls of sprouts and broccoli, 28 yung sprouts and cauliflower, and 22 yung broccoli and cauliflower, and 13 yung sprouts. So, how many do not like any of the vegetables? So, to compute that, gagamitin ng formula from previous page. So, I select muna and next slide. So, ayan, from the given, itong first part, i-add lang. Same ito. Itong second part, din yung mga intersections nila. And then, i-add yung totality ng intersection. Lahat ng set. And that will give answer ng 154. And then to get yung number ng students with any vegetables. From the given of 120, ima-minus lang yung 154. And that is 16. So do not like any of vegetables. So, yeah. So ayun lang po. So, member kami si Jocelyn, the Best Mendoza. Same the respect, Samantha, Peter Rivera.
Okay. Alright. Good job. Ayan. So, meron pa tayong time para dun sa ano, no? Kasi, meron lang akong kailangang i-discuss. So, wait lang. Audible ba ako? Audible? Maliwanag
Yes po,
niyo ba akong
ma'am.
naririnig, class?
Yes po, ma'am.
Okay, alright. So, kasi yung ating final presentation ng ating mga project is fast approaching. That will be in 2 weeks, no? So, yung next na week, that will be the last presentation ng ating mga reporting. Now, looking at our yung ating mga presenters, we still have 3, no? So, yung group 5, group 4, at saka group 3, no? So, yan po yung hindi pa natin, no? So, wala sila. So, anong gagawin natin? Last na yung 10, no? Next week, last na session na natin yun, and then we will go for our, final presentation na, no? Okay. So, para rin maliwanag, isama na rin natin sa last discussion natin ngayon yung So, yung ating final presentation ng ating projects presentation will be, lagay natin sa GC, in Feb 18. Ayan. Feb 18. 2023. Okay, so para tayo sa schedule. Now, what shall we do with the other groups? Okay, copy lang natin. Nasaan na yung para okay, may baseline tayo. So, nandun po ako sa GC ngayon. So, probably maganda nandun din kayo. So, what will group 5, 4, and 3 do? So, ang gagawin nyo po ganito. Yung inyo pong presentations, kasi 3 grupo kayo, ilagay po natin yung ating, para po tayong nag-present na nakalagay sa video. No? So, video. We'll create a video presentation of our report. Ayan. So, para dire-diretso. Now, yung pong ating video presentation ng bawat itong group na to, yung 5, 4, and 3, sila lang po yung, kasi sila na yung last. Para ma-maximize natin yung time na naka-assign sa atin, so we are starting from 7:30 until 10, kasi 10 na tayo ngayon. 10 yung so I am assuming na mga at least 45 minutes, no? Ang pwedeng magamit. The less the better, no? Sorry. 45 minutes each. Ayan. 45 minutes each yung video or less. No? Or less. Ayan. Okay. So, siguro wala na tayong masyadong Q&A kasi siguro sagad na yan. But anyway, para hindi naman talo itong yung last 3 natin na groups, para makapag-present din sila, no? So, i-concise natin yung yung ating video presentation ng ating mga slides into 45 minutes or less for each of the of this group, no? Ayan. So, yun po yung gagawin natin next meeting para saktong matatapos natin hanggang kay group 3. Probably yung kay group 3 yan yung pinakamaikse kasi isa lang yun sa kanya, no? Ayan. Okay. So, ayan. Okay. Yung pong ating at saka meron din pala akong inad dun sa GC, no? So, ang napapansin ko kasi dahil meron tayong application ng Python dito sa discrete structure, yung interpretation niya kay Python nagdadalawa. Merong portion ng statistics, may portion siya ng ng machine learning, no? So yung last dun sa ating and then mathematics, yung kay combinatorics, permutation, ayan, so medyo may pagkamat yan. So may makikita kayong ini-extend akong mga mga links dun sa inyong GC. So ito naman kay bias theorem, ito naman ay machine learning naman ito, no? So and then you have Fibonacci sequence. Again, this is algorithm, no? So para meron tayong application dun sa ating ginagamit na tool, which is Python, di ba? Python nga yung ginamit natin sa presentation. Now, if you would like to use this tool for what?
Possible delivery from Shopee.
Okay,
Maybe, I don't know. I'll call you later.
but just put it there so I would know. All right. So, ayan. So, nilalagay ko dyan, no? Kasi, di ba, tayo ng final presentation ng ating project. For those who would be updating their, or who would like to make use of this tool, no? Dun sa Python, no? Baka gusto nyo lagyan ng Fibonacci sequence, ayan. Bias theorem, i-apply natin. So, ayan. Nilalagay ko dun sa, sa link, no? Also, dun sa mga wala na kasi kayong time I don't know if you're if you have already done something with your projects. Kasi merong iba ata sa inyo babaguhin yung kanilang ginawa. I would suggest wag nyo na lang baguhin, i-improve nyo na lang, dagdagan nyo na lang ng improvement, no? Kasi unless na nasimulan nyo na, no, nakapag-project na kayo at na i-incorporate nyo na yung gusto nyong baguhin or gusto nyong application na gustong gawin, then sige, well and good. Pero kung ngayon nyo pa lang siya babaguhin, baka hindi kayo umabot sa time, no? So, suggestion lang naman, pero still, that is your choice. Now, yung mga application nyo na baka pwedeng konting improvement na lang, no? And then you have itong mga additional na tool na inaral natin, no? Baka gusto nyo ring idagdag. And then, these are the interpretations, no? Okay. So, ayan. Yun na yung sa side ko, no? Na i-clarify ko lang, no? So, right. Okay. So, dito tayo. I-end natin yung ating discussion dun sa ano bang chapter yung tinapos ni okay, para dun sa topic. Ayan. Nilagay ko na dito eh. Okay. Okay. So, si Group 6 ay natapos dun sa Chapter 8, Advanced Counting Techniques. Ayan. Para po dun sa ating sa ating attendance. Yung topic. Okay. Chapter 8. So, maliwanag po ba yung instruction dun sa last 3 groups? Okay. Yung last 3 groups natin ay group 5, 4, and 3. So, tanungin natin, i-confirm ko lang. Group 5, maliwanag. Okay, group 5. Sino yung naandyan yan? Na member? Okay, anybody from group 5? Pwedeng pakitaas ang kamay para lang sa confirmation. Okay, ayan na si Miguel. Alright. And then, group 4. Pakitaas po ang kamay, group 4. Okay, salamat. Okay, maliwanag. And then, group 3. Group 3. Okay, good. Kinatasya na. Alright, thank you. Ayan, so na-confirm na natin, maliwanag yung instruction natin. Okay. So, tayo po ay umabot na sa oras. Ayan, so i-check lang natin sa attendance. So, kanina nag-start tayo ng 20, no? And then, sabi ko, yung 19 nasaan na dun sa GC. Ayan, at least mag-e-end tayo ng 32. Ayan. Now, Tashana, ilan yung kulang natin sa 32? Para lang sa natin, pang-ending.
7 po, ma'am.
Okay, so may wala tayo na 7 ngayon. Ayan, para sa attendance. Kasi naman tayo, naka-video. So, para lang may recording purposes tayo. So, anyway, balik ako dun sa question ko. Meron ba kayong clarification and anything na gusto nyong dun sa instruction na sinabi ko previously? Any clarification? Yes, Tashana?
Ma'am, yung sa may final project po namin, yung documentations po, magkapares pa rin po ng format
Correct,
ng last.
correct. Yeah. We'll be using the same format.
Okay po, ma'am. Thank you po.
Okay. Alright, anything else? Yes, Bernard. Bernard. Taas ang kamay.
Hello po, ma'am.
Oh, sige, ano?
Doon po, ma'am, sa flowchart tsaka pseudocode, pwede pong iba po ang gamitin o yun po talaga? Like activity diagram, ganon.
Anong gusto nyong gamitin?
Pwede po, ma'am, gumamit ng activity diagram.
Pwede naman, no? Gusto nyo, gamitin na kayo ng class diagram at saka, state chart. Joke lang.
Okay
just,
po.
Just
Thank you po,
use
ma'am.
what is appropriate to your application.
Sige po, sige po. Thank you po.
Okay. Wait lang, pwedeng tanungin, why do you want to use activity diagram?
Parang mas madali po gamitin sa sa code po namin.
Sa code ninyo.
Parang
So, mas appropriate, mas madaling i-interpret.
Opo.
So, kumbaga activity, puro function, ganon.
Opo.
Okay. Alright. So, kung ganon, naka-object ba yan? Pwede rin kasi yung object diagram. Kasi kung naka-function yan, definitely baka nilagay nyo sa object. But anyway, kung mas komportable kayo sa activity diagram, then use, pa rin. Kasi naman din yan pareho lang din yan ng flowchart. Ibang format lang pagdating sa UML. Magandang practice yan kasi usually nagpapagamit ako ng mga UML tools sa sa BSIT Pero sige, para i-clarify nyo yung inyong procedural process. Pwede naman. Sige, okay lang.
Thank you po, ma'am.
Alright. Sige, anything else? Teka, meron tayong chat dito. Ma'am, kailan po ang deadline ng recorded video? Ipe-present nyo na yan sa 10 Then definitely dapat ready na yan sa 10. Joshua, gagamitin nyo yan sa 10. So, definitely dapat nandun yan, no? So, hopefully ready na yan. Okay. Maliwanag ba, Joshua? Sa 10, dapat ready na siya kasi ipipresent nyo yan on that day. Okay. Sige, salamat. Okay. Alright, any other clarification? Okay. Right. Sige, pagka may question kayo, i-set up nyo lang dun sa sa GC at sasagot naman ako. Make sure naka-call out, no? Okay. So, doon pwede na tayong mag-ending kasi hindi pa tayo ni-remind ni si Shane. Okay, Shane. So, hindi bale. 10 naman talaga is na. Okay, so kung wala na po tayong question. Sige. Doon na lang po sa attendance sa chapter 8. Chapter 8, doon sa topic, Advanced Counting Techniques. Ayan, doon tayo nag-end, no? Alright. Okay, sige, thank you. You may now proceed to your next class. Thank you for coming today. Ayan, happy weekend. Sabado ngayon.
Thank you po, ma'am.
Alright, thank you.
Thank you po, ma'am.
Okay, sige. Bye. Saan ba yung mga na yan? Yung react. Okay. Diba? Makikireact din ako. Ayan. Alright. Okay. Sige. I-end ko na rin yung aking video.